Welcome my dear learners for this course on operations research. In this module 2 we were discussing on analytical solution for linear programming problems. In our previous lecture I introduced you people to the concept of duality in linear programming problem. In today's lecture let us solve a numerical problem on dual simplex method. The problem states that solve the following linear programming problem using dual simplex method. Z minimum is equal to x1 plus 2x2 plus 3x3 subjected to the constraints 2x1 minus x2 plus x3 greater than or equal to 4, x1 plus x2 minus 2x3 less than or equal to minus 8, x2 minus x3 is greater than or equal to 2, x1, x2, x3 are all positive variables. As we already discussed in our previous lecture, we have learnt how to write dual for any given primal. In case of dual simplex problems, always we should start the problem from the standard primal LPP. The given linear programming problem is in its primal form. Now verify whether it is its standard primal form or not. A standard primal is one whose objective function is always maximization and the constraints will have always less than or equal to sign and all the variables are positive. Now if I observe the objective function is minimization, which is not correct. For a standard primal the objective function should be maximization and all the constraints should have less than or equal to sign. So therefore first write down the standard primal from the given primal. So if I move for solution, write down the standard primal. For standard primal we will solve using dual simplex method. So the standard primal will become what? Z max is equal to minus x1 minus 2x2 minus 3x3. Correct? So this is subjected to the constraints. So we have greater than or equal to sign, hence multiply negative, it will become minus 2x1 plus x2 minus x3 is less than or equal to 4. Then we have x1 plus x2 minus 2x3 less than or equal to minus 8. This I multiplied by minus, so therefore it should be minus 4. Correct? And we have minus x2 plus x3 less than or equal to minus 2 and we have the positive constraint x1, x2, x3 are all positive. Now this is the standard primal. Now we should solve for this standard primal. Now I should convert all the constraints to equation, therefore I should add slack variable, right? I'll add s1 here, I'll make it as equation, s2 and make it as equation, s3 and make it as equation. So if I do that, so once you obtain the standard primal, now add slack variable and convert all the constraints to equation form. So if I do that, I'll get the objective function as plus 0s1 plus 0s2 plus 0s3. Here I should add the slack, hence this will become plus s1 less than or equal to minus 4 plus s2 less than or equal to minus 8 plus s3 less than or equal to minus 2 and all these are positive values. s1, s2, s3, the slacks all are positive. Now we have obtained the equations, right? So that is why we added the slack. Why I am writing it less than or equal to. In order to obtain the equation, we have added the slack. So we have converted all the constraints to equation by adding slack variables s1, s2 and s3. Now this is in the required simplex form, right? Now construct the simplex table Through solving the problem, I will explain how to solve using dual simplex method. The first step is that always write down the standard primal. So once you obtain the standard primal, add slack variables and convert all the constraints to equation, which will be in the required simplex form. Now construct the simplex table. So if I go for simplex table, first we have basic variable. First we have basic variable. Under basic variable we have S1, S2, S3, and then we have XB. The coefficient of basic variables are 0, 0, 0. Then we have CB, RHS of the equations, that is -4. Sorry, this is coefficient, right? This is CB, coefficient, and here we have XB. RHS of the constraint equations, that is -4, -8 and -2. So here we have Zi, which is equal to CB into XB is equal to CB into XB, which is equal to 0. So construct the simplex table. And also note down xi, ci. Ci is nothing but the objective function coefficients, that is -1, -2, -3, 0, 0, 0. We have -1, -2, -3, 0, 0 and 0. We have x1, x2, x3 are variables. We have slacks s1, s2, s3. So construct the table. No need to calculate the ratio of xp by xk, just you write down the required row operation. Row operation. Now fill this matrix. We have the coefficients as -2 plus 1, -1 plus 1, 0 and 0. Here we have +1 plus 1, -2, 0, 1, 0, and finally we have 0, -1 plus 1, 0, 0 plus 1. So this you know how to do. So this is step 1. Now calculate the delta. Let me write it that side. So delta I is equal to Zi minus Ci. So Zi is 0. So Zi is 0. So negative of Ci, this will become +1, +2, +3, 0, 0, 0. So this is the starting simplex table, which you know how to write. Now always in case of dual simplex method, start in the first step, write the given linear programming problem in its standard primal form. In step 2, find the living variable, variable or vector is minimum of xb. You should consider only negative values. Only negative values means what? In xb we have -4, -8, -2. Minimum means what? Since we have negative sign, the highest numerical value is the minimum, correct? So minimum of -4, -8, -2 is -8. So therefore s2 is the living variable. -8 is the minimum xb. I have found it out. Now you calculate the value of ratio of delta I by yi. Ratio of delta I by yi means we have delta I calculated divided by we have root 2, correct? So therefore you should take the ratio of y2. So entering variable will be is maximum of the ratio of delta I by yi, only negative values. We should consider only negative values. We should not consider positive values. Now calculate the ratio and find out the maximum value of the negatives. Since it is a negative, it will become opposite. Numerically least value is the maximum ratio, right? So 1 by 1 is 1, 2 by 1 is 2, 3 by -2 is -3 by 2, 0 by 0 is infinity, leave, 0 by 1 is 0, 0 by 0 is infinity, you leave. So the only negative is -3 by 2. So therefore there is no comparison. We should consider only negative values. So this is the entering value. If I have 2 here, then I should go for this is -1.5, this is -2. Again I should go for this itself, because -1.5 is greater than -2. I should go for this one. If I would have -1, -2, -1.5, then I will go for this one, because -1 is maximum compared to -1, -2, -1.5. So now we have only one negative, no need to worry much. So this is the entering variable is x3. So therefore if I write the simplex table for step 2, we have s1 basic variable, x2 is leaving, x3 is entering, we have s3. So next is step 2. So this is step 2. Now this is the key row. So therefore R2 of step 2 will be R2 of step 1 divided by the key element is -2. The key element is -2 divided by -2. R2 of step 1 divided by -2. So R2 of step 1 divided by -2, x3, coefficient of x3 is -3, coefficient of s1 is 0, s3 is also 0. So now from here you divide throughout by -2, -8 by -2 is +4, this will become +4, and then we have -1 by 2, and then we have -1 by 2, we have +1, 0 by anything is 0, we have -1 by 2, 0 by anything is 0, correct? So I obtained the key row. Now I should make this as 0. So therefore R1 of step 2 is equal to R1 of step 1. So we have plus 1, so just you add plus R2 of step 2. R3 of step 2 is R3 of step 1 minus R2 of step 2. So we have minus 2, sorry, we have plus 4, we have minus 4, we have minus 4 here, we have plus 4 here. So minus 4 plus 4 will become 0. Here we have minus 2, here we have minus 1 by 2. Minus 2 minus 1 by 2 will become minus 5 by 2. Here we have 1, here we have minus half, it will become plus half. Minus 1 plus 1 will become 0. 1 plus 0 is 0, it will become minus half. Here we will get 0. Right? Here we have plus 4, here we have minus 4. Minus 4 plus 4 is 0. Next here we have minus 2, here we have plus 4. So I should subtract. Minus 2 minus 4 is minus 6. Here I have 0. Here I have minus 1 by 2. It will become plus 1 by 2. Minus 1 plus 1 by 2 is minus 1 by 2. Here I have 1. Minus 1 is 0. So this will be 0. Here I have 0. Plus 1 by 2, it will be 1. Now moving for the value of z. So here I have 0. I should make this as 0. So therefore here I can't write delta, right? So let me replace it. So now I want R4 of step 2 is R4 of step 1 minus 3 times R2 of step 2. So here I have 0, here I have 4, 4 3s are 12, it will become minus 12. Next we have 1 here, here we have 3 by 2, so therefore it is 1 minus 3 by 2, which is 5 by 2. Here I have 2, so 2 minus 3 by 2, which is plus 7 by 2. Here we have 3, it will become 0. Here we have 0, here also we have 0, it will become 0. Here we have 0, here we have minus 1 by 2. So minus of minus will become plus, it will become 3 by 2. Here also 0. Done. So once you have done this, now calculate. Now the most negative value among this is minus 6. So therefore this is a living variable. Living variable is 3. Now we calculate the value of delta. Delta, that is ratio of delta I by y3. Third row I should take. So calculate the ratio. So delta is this one, this by this ratio. So 5 by 2 by 1 by 2, it is 5. Here I will get 7. This is infinity. Here we have minus 7, right? Here we have minus 1 by 2, so therefore this should be minus 7. This is plus 5, this is minus 7, and then we have plus 3. 0. Done. Now we have only one negative value, that is -7. So therefore this is the entering variable will be x2, leaving is s3. So moving for step 3, we have in step 3 we have the basic variable as s1, x3. Now x2 is entering. Coefficients are 0, x3 coefficient is -3, x2 coefficient is -2. Now I should perform the row operation. We have the value of z. Right, coming for row operation. So we have this as the key element for us. So R3 of step 3 is equal to R3 of step 2. R3 of step 2 is multiplied by -2. R3 of step 2 is multiplied by -2. So we have -6 minus 2 is plus 12. 6 2s are 12. Minus of minus is plus. 2 will get cancelled. We have -1. We'll get -1. Then here 2 will get cancelled. Minus of minus is plus. We'll get +1. That is what I require. We got +1. Here we have 0 into anything is 0. Here also 0. Here 2 will get cancelled. -1. We have -2. Right? Now coming over here. So R2 of step 3 is R2 of step 2. So we have 1, we have -half, it should be +half, plus R3 of step 3 by 2, R3 of step 3 by 2. So 4 plus, we have 4 plus, we have 12. 4 plus 12 by 2 is 10. 4 plus 12 by 2 is 10. Next, here we have -half plus, we have -1 by 2. -1 by 2, that is -1. Next we have -half plus half will become 0. Here I have 1, here I have 0, it will be 1, it will be 0. Here I have -half, here I have -half, it will become -1. Here I have 0, here I have -2, -1. Next, here I have +1 by 2. So to make it as 0, so R1 of step 3 is equal to R1 of step 2 minus R3 of step 3 by 2. So minus, so that will become 0. 0. Here I have 0 minus 12 by 2, which is -6. Next, here I have -5 by 2, minus we have -1 by 2, which is -2. Next we have 0, here I have 0, here I have 0, it will be 0. 1 and 0, it will be 1. Minus of -1, that is -half -1 minus of -1 by 2. it will become 0. Next we have 0, here we have -2, it will become +1. Now we calculate z, we have -12. So before that I want row operation, I should make this as 0. So therefore R4 of step 3 is R4 of step 2. Step 2 -7/2 R3 of step 3. R3 of step 3. So -7/2, it will become 0. So we have -12 minus 7/2 times, I have 12 here, 12, which is -54. -54 is what I am getting. If I cross check, I will get the same. 12 to the 24 plus 30, 54, correct. Now here I have 5/2. 5/2 minus 7/2 into R3 is -1, which is +6. Zero. So here I have 0, here I have 0, it will be 0. 0 and 0 will be 0. Here I have 3/2. 3/2 minus 7/2 into -1 plus 5. So here I have 0, here I have -2 plus 7. Done. Now the most negative is this one, so this will leave. So minimum of xb is -6, so this should leave. Now to calculate the entry variable, we don't have space. Let me rewrite it once again. I have rewritten step 3. As I said, -6 will be leaving. Now we calculate the value of ratio of, calculate the ratio of delta I by y1, first row, it is row 1 I should take. So here delta is 6 0 0 0 5 7 7. Take the ratios. So 6 by -2 is -3. So 0 by 0 is infinity, leave it. 0 by 1 is 0, positive, leave it. 5 by 0 is infinity, leave it. 7 by 1 is 7, which is positive, we can leave it, because we should consider only negative values, which I clearly stated, only negative values, delta by y. So first row, y1, row 1, 6 by -2, 0 by 0, 0 by 0, 0 by 1, 5 by 0, 7 by 1. The only negative is -3. So this will be the entry variable. Clear? So y is nothing but row value, row 1. Now if I go for step 4, S1 will leave, X1 will enter. X1 will enter. Coefficient of X1 is -1. We have X3 and X2 as -3, -2. Correct? Now we want how much is the z value. For that I should perform the row operation. So this is the key row. R1 of step 4 is equal to R1 of step 3. So this is the key element. R1 of step 3 divided by -2. R1 of step 3 divided by -2. So -6 by -2, minus of minus will get cancelled to become just 3. -2 and -2 is 1. 0 by anything is 0, 0 by anything is 0, minus half, 0 by anything is 0, it will become minus half, minus half. Next I should make this as 0, just addition. So R2 of step 4 is R2 of step 3 plus R1 of step 4. So 10 plus 3 is 13. This will become 0. Just addition. 0 plus 0 is 0. 1 plus 0 is 1. 0 plus minus half is minus half. Minus 1. We have minus 1 minus half. Minus 3 by 2. Next, here also we have minus 1. Again just addition. R3 of step 4 is R3 of step 3 plus R1 of step 4. R1 of step 4. So 12 plus 3 is 15. Minus plus 0. 1 plus 0, 0. 0, 0, 0. 0. Minus half. Minus 1 and 0 is minus 1. Minus 2 minus half. Minus 2 minus half is minus 5 by 2. Done. Now I want this to be 0. So we have 6. So R4 of step 4 is R4 of step 3 minus 6 times R1 of step 4. So minus 6 times R1. This will become 0. So how much here? Minus 54 minus 6. Minus 54 minus 6 into 3 is minus 72. Minus 72. We have 0. Here also we have 0. 0. Here also we have 0. 0. We have minus 2. Minus 2 minus 6 plus 6 by 2 is plus 3. Here we have 5, here we have 0, it will be 5. Here we have 7, here we have minus half. So 7 minus 1 by 2 into minus, we have 7, minus of minus is plus, 7 plus 6 by 2. 7 plus 6 by 2 is 10. Done. Now the careful observation reveals that XB values are positive. If XB values are positive, the problem terminates. We should solve in dual simplex method until we get all the values of XB as positive. We got all the values of XB as positive, hence the problem terminates. Once all the entries of XB column are positive, the problem terminates. The problem terminates and we get optimal solution. And we get optimal solution. So all the entries are positive, hence the problem terminates. We got the solution for this problem, and the solution is, so optimal solution is Z minimum is 72, where the values of x1 is 3, x2 is 15 and x3 is 13. x1 is 3, x2 is 15, x3 is 13. So if I look at the question, we have x1 is 3, 3 plus 2 into 15 plus 3 into 13, which is 72. which is correct. So the solution for this problem is z minimum is 72 and the values of x1, x2, x3 are 3, 15 and 13. This is how we should solve problems on dual simplex method. First convert the given LPP into its standard primal form and adding slack variables get the starting simplex matrix, and solving which we have the living variable is minimum of xb, that is highest numerical value with negative sign in xp column is the living row or living variable. Entering is the ratio of delta by corresponding row which is leaving. The highest negative, maximum of this ratio you should take. So maximum means it will become least negative value. So least value with negative sign is the entering. So using which you keep proceeding ahead until you get all the entries in the xp column as positive. Once all the entries in xp column are positive, the problem terminates. We got the optimal solution. So this is how you should solve problems on dual simplex method. That's all from this lecture. Thank you all.